Our lesson today, lesson 5 of chapter 1, will be simplifying algebraic expressions. Some rules that we're going to follow here as we're simplifying all these terms. These are the like terms rules. How do you know which terms are alike and you can simplify them? Rule number 1, their exponents must be the same. Here we have a second power, we have an exponent of 2, and we have no exponent. That's not the same. These would be the same over here. Variables must be the same as well. So meaning that A is one kind of variable, B is a different kind of variable. So if you have an A and a B, that's going to be, or a B and a C in this case, that would not be like figures. Then coefficients don't matter, meaning that the 4 or the 10 and then the 134 over here, that doesn't matter. The 3 and the 2, that doesn't matter either. So let's kind of look at these ones and see if these are ones that we can combine. Are these terms like terms? We have 5a. We have 5a squared. Rule number 1 got broken, huh? Exponents must be the same, so you could not combine these terms together. 3b to the third and 2b to the third. Their exponents are the same, good. Their variables are the same, good, b and b. And then remember, coefficients don't matter, so the 3 and the 2, that doesn't matter. You can combine these terms. So just to keep track here, this is a can't, this is a can. We have 4b and 4c. Rule number 1 is okay. The exponents are the same. Rule number 2, variables must be the same. This is a b, this is a c. That's not okay. So this is a can't. We have 10 times e and then 134 times e. No exponent here, so that means they're the same. E in both cases, that's a good sign. Remember, coefficients don't matter, so we're all set there. So this is can. Let's move on and try some of these problems then. To actually simplify them, if they are the same and can be simplified, you just add or subtract the coefficients, the numbers that are multiplied times the variable. We kind of have the rules up here for reference if you need it too. We have 3a squared plus 5a squared. See, we have the same exponent, the same variable. Now the coefficients are different. We need to add them here because it's telling us to add. So 3 plus 5 would be 8a squared. All right, let's look at this then. 15c to the third minus 3c to the third plus 5c. Let's see if we can combine these two. Same exponent, same variable, c and c. Okay, we have 15 minus 3 then. So we're going to get 12c to the third. And then we have plus 5c. Let's see if we can combine these now. We have exponent of 3, no exponent. That means we cannot combine these. So when you can combine it, you just leave it at that. Just no simplifying that needs to be done beyond that. Let's look at these problems then. It tells us to simplify, also to use the properties we learned a few lessons ago, the commutative, associative, distributive properties whenever necessary. Meaning that we can add, remember, we can add these in any order. We can group things together with like associative. We can distribute when we're multiplying. So just always keep that in mind, that we can use these properties to solve these. For example, this one, 3a plus 2b. We can simplify those, but look, 3a is over here. There's a 5a over here. Remember, we can add in any order. So we could do 3a plus 5a plus 2b plus 4. So that's the commutative property, right? So we can do 3a plus 5a, which would give us 8a plus 2b plus 4. Can we combine these? Certainly not, because the variables are different. And then this one has a variable, this one does not, meaning they can't be combined either. So this is where you leave it. That's as simple as it gets. We have q squared plus 2q plus 2q squared. So we can't combine these because this has an exponent and this does not. But this one over here does. So let's rewrite this problem again. Q squared plus 2q squared plus 2q. So now we can simplify this. This really is a hang-up for some people. They struggle. There's nothing in front of the q. So what does that mean? Whenever that happens, that just counts for 1. Remember identity property? You just multiply it times 1. So now there's a 1 in front of the q. So that's a good way to fix that. You can make this a 1, 2, 1a, or 1b. So we have 1q squared plus 2q squared. What's 1 plus 2? That'd be 3q squared. And then we have plus 2q. So that'll be as simple as it gets. Remember, we can't combine these two. We have a plus 2b plus 2a plus b plus 2c. So let's get the A's all together with commutative property. We'll get the B's together in C. So let's rework this here. We have A plus 2B, plus 2A plus 2B plus B plus 2C. So if we're going to simplify this, the A's can be simplified. Remember 1A plus 2A, so that'd be 3A. We have 2B plus, remember, 1B, so it'd be plus 3B. And then we have just 2C left over at the end here, so we can just put that 2C in there. And this is as simple as you get it to. None of these can be combined. Here's a kind of a critical thinking problem here. We have write an expression for the perimeter of the given figure, then simplify the expression. Remember, for a perimeter, we just add all these together. So we can just do that here. We can write that down. We have 3A over here. Moving over clockwise, we have plus another 3A, then plus 2N, plus 5A, plus then one more 2N over here. And then, like commutative property, we can reorder this. We have 3A plus the 5A plus 2N. Now we're going off the screen, so let's adjust that, plus 2N. So now we can add these together. 3A plus another 3A is 6A, plus 5 would be 11A, plus 2N would be 4N. So this would be our simplified answer for that, and that's as simple as it gets.